This conference will now be recorded.
So, so when we started talking about the first step, we started talking about data extraction. So we had talked about we clearly identified four questions. So first of all was, for what vintage of data should we use? For what variables, what should be the variable be extracted? What should be the type of accounts that should be extracted? What are the checks and reconciliations? So these are the four questions to which we have kind of framed the answer, right? So for each of them, we have the respective answers, answers that we had discussed in yesterday. Now, after the data has been extracted, so the second step of the discussion, the second step of the model development exercise over here is going to be the data quality check exercise. So we need to understand how is it that this data is being created, or what is it exactly about. So how is it that the data will be, so how is it that the data will be created, how is it that the data will be kind of checked, right? And how is it that the variables are to be reduced? So from the second step, as we initiate the data quality check exercises, one very important thing initiates, that is your variable waterfall. The data quality check. Now, one of the most important characteristics, or one of the most important, uh, one of the most important concept of the data quality check is to initiate the variable waterfall. Initial variable waterfall exercise. Now, when I talk about the variable waterfall, right? So there are a few things. Now, when I talk about the variable waterfall comprises of reducing the variables, or excluding the variables at each stage of the analysis. So at each stage of the analysis, a set of variables are excluded basis their basis their explanatory, or basis certain criteria. Now, what are the basics, bases for which, what are the basic criteria using which they are on ground of which variables are removed? So the first and the most important criteria is the redundancy of the variable. So this is the first and the most important part. Redundancy of the variable. Now, when you are talking about redundancy of the variable can be redundant in two possible ways. One is scope redundancy, which is not variables which do not reflect the borrower's risk, or the transaction behavior risk or transaction risk are removed. So those are examples of scope redundancy, which is already done at the time of the data extraction exercise, right? So that is one of them. So once you get the final variable list, you look into them and you say that, hey, look, these are the variables that I don't need for model developers. That's scope redundancy, right? And the second set of redundancy that we talk about is the occurrence redundancy. So they are kind of assumed to be redundant basis the occurrence. The occurrence redundancy. Now, under the occurrence redundancy, what we generally have is we have the first occurrence, last occurrence analysis. So variables which are kind of which are very regular in terms of their occurrences. What type of exclusions happen over here in terms of redundancy? So first is your out of scope variables. Out of scope variables, right? And occurrence redundancy are those variables which are removed in terms of their irregularities. In terms of irregularity. So irregularity in terms of the occurrence, which is your first occurrence, last occurrence analysis. So basis redundancy, a set of variables will be removed. The second set or the second criteria of the variable waterfall, the next criteria of the variable waterfall will be the completeness criteria. So it talks about how many variables or how complete are the variables. So over here, what we generally get to talk about is the completeness. So how complete are the variables? Now, completeness analyses are nothing but the missing observation analysis. So how like out of these variables which are redundant, which are not redundant, what we try to check over here is the missing percentages. This is where your missing observation analysis comes to place. Now, basically, there are two ways, right? If there are one way is to treat the missing observations, and the second way is to assess the missing observation or to say that okay, so one way is to treat the missing observations, or in case where the variables have when a variable has multiple when there are multiple months when there are missing observations, then those missing observations are to be treated. I mean, then those variables are dropped. Now, this is where the missing observation analysis comes into place. So this is basis your completeness. This is the missing observation analysis. The third that we have over here is, so once the completeness criteria is done, so once you have seen that the variables are missing or not, out of the variables which are not missing, you move to the next step. Now you are looking into the structural characteristics of the variable. So is there a case when the variable is behaving in an abnormal manner, right? So the second point that we put over here is the structural or the structural stability or the over or the behavioral stability of the variable, right? More or less the structural stability of the variable. So how now within structural stability or assessing the structural stability, there are two types of variables that we need to assess. One is the continuous variables, and the second are the categorical variables. Others are the categorical variables. Continuous variables or the categorical variables. If the variables are kind of continuous variables, then so if I talk about a continuous variable, then for the continuous variables, the analysis that we do are the univariate analysis. And the second analysis and the second set of variables that we have are the frequency distribution analysis. So these are so at this stage, I'm trying to assess the variable based on the structural stability, trying to assess whether there are any abnormal spikes or there are any abnormal movement in the time series, right? So does the continuous variables are the continuous variables stable enough, or is it that there is some kind of a problem? So I have this, right? So the entire objective of this analysis is to check whether there are unnatural spikes in any of the variable, whether unnatural spikes observed. So whether unnatural spikes are observed in any one of the variables. So this is something that we want to assess over. So now the question that comes out over here is that how do we do each of these analysis? The first two set waterfall has been care of the variable exclusion, observation exclusions, and in the first occurrence, last occurrence analysis. So the third one, what we are trying to do is we are trying to assess the missing observations. So what we generally do is we take up. So for this missing observations analysis, do a chain analysis of the missing percentage. Get a trend analysis of the missing percentage. And when we get a trend analysis of the missing percentage, what we need to do is that we need to understand that each of these, or how is it that each of these variables, or so what we do is we identify the trend analysis, and if a variable has missing values in multiple months, then those variables are removed from the analysis. Right, so let us summarize this part once again. So if there are missing values, if percentage missing is greater than 0, then like for multiple months, then the variable is removed. The variable is removed from the. When I say it is removed, so this variable is removable if the missing happens at an accountable information. Missing, the unique identity is missing, or product ID is missing, or a product category is missing, or a limit for balance is missing. Then those cannot be removed. They are very critical variables, and they have to be kept within the card. I mean within the data. In such an exercise, you go back and you have to re-extract the information. Right? Now, the next question is, can you impute the data or not? Now, missing imputation is not always possible. If the missing happens corresponding countable information, the only solution that you have is to go back and extract the data. On the other hand, if you have your missing values can be a person can arise as a result of the overall behavior, right? So So it can happen as a behavior of the variable or as a definition of the variable. Now, in such a case, what we can do is we can, uh, you know, so if it's a part of the definition of the variable, then we cannot do it. But what we can do decategorize. So let's say uh, Okay. So as I was saying, so now am I audible? Can you hear me? Okay, fine. So what I'll do is, so let's continue. Yeah, so as I was, if the variable is a very important variable, then it cannot be removed, and also it happen sometimes that it is the definition of the variable. Variable is defined such that there is missing value. Let's say, for example, overdrafts, right? ODs. Now, overdrafts are of two types. So one is an authorized overdraft. One is an authorized overdraft, and the other is an unauthorized overdraft. Definition of the variable, you cannot do any imputation exercises, right? Let's say uh, a variable like date since last delinquent. Now, over here, if an account has never been delinquent, that variable will not be populated for them. So, in such a case, it is important that we sub them with certain special values. So, these are some of the important questions, these are some of the important points that we have that we need to put it in. Right. So now, once the missing values are taken care of, then the next part that comes into that comes to play over here is that of the structural stability, where we are trying to assess whether the variable is a continuous variable or a categorical variable. If the variable is a continuous variable, right, our objective is to assess whether the variable has any issues with any abnormal spikes in the basic moments of its distribution, right? And hence, what we do is So what are we trying to do for the univariate analysis? So when we are doing the univariate analysis, we're trying to look for spikes in the basic moments of the variable. In moments of the variables. Spikes in basic moments of the variables. Right? So if there is a spike in the basic moment of the variable, then in any of the basic moments of the variable, then that is kind of assessed, that is analyzed, and based on that, we decide on whether there is supposed to be a trigger or not, right? And how do we do that? So what we do is we look into the long run behavior of each of these basic moments over a period of time, then calculate the long run mean and compute the Z stat over there. Right? We compute the Z stat. And once we compute the Z stat, right? So as long as the Z stat is less than 3, we say that okay, the shift or the spike is not a significant spike. So it is green. And if the Z stat exceeds 3, I mean, or is 3 or exceeds 3, we say that it is a red. Right. So there are pattern measures as well. So we have the spikes in the basic moments of the variable. So we have the Z stat. So if it is less than 3, we put it at green. If it is greater than equal to 3, it is at red. Now, if a variable has a red, if it shows a pattern or a continuous pattern of red, or it moves from being amber to red, then we know that the variable has kind of continuously deteriorated, or the the spike comes out, or let's say are surrounded by a green, there's a suddenly red spike, and that happens intermittently. You know that those variables are kind of in a risky manner. So that is something that we need to develop. That is something that we need to work on, right? So if a variable has multiple instances of red across its decided distribution across the variables and so on, then you know that that variable is not in a correct state to be used for the next levels, right? So you know that that variable has certain issues. So let's say, for example, in a particular month, the mean is red and the max is red. So it means that the mean for that month has an abnormal spike corresponding to the mean value of the other months. And that mean is being driven by an outlier, the apparent outlier, the max value. So you know that in such a you can use a capping flooding exercise and you can take care of that value, right? So that problem can be easily taken care of. So we have so a similar analysis has been done for the other retail product using the the loan stats data. So after this univariate analysis is done, a similar exercise is also done for the categorical variables, just to understand. So for the categorical variable, if there is a spike in the frequency distribution, then we would say that, hey, look, there is a spike in this distribution, and the reason that there is a spike is because, right, so and is a spike is there is an abnormal concentration. So over here, if I'm to talk about the frequency distribution, right? So spikes in the frequency distribution would imply an abnormal concentration. So spikes in the frequency distribution implies abnormal concentration. The frequency distribution this implies abnormal concentration. Okay. So there is an abnormal concentration that we have. It implies an abnormal concentration. So the abnormal concentration is kept in the Z statistic, right? So over here, what we get to see is that that as you know, so at this step, at the stage of data quality check, right? At this particular stage of the data quality, what we are trying to see over here is we are trying to see that those we are trying to select those variables which are structurally more or less stable, which do not have too much spikes in their behavior. So here I'm trying to just select out those variables which are in the structurally stable, right? So that's the third level of variable selection that happens. Now, after the structural stability condition is met and you have final set of variables which enter into your model, right? So after that, the next level of variable selection happens based on the predictive capability of the variable. Over here, we have the next set of exclusions which happen is on the predictive capability of the so variables which are predictive or which are the most predictive are kept back. So the first set of extraction is basis the informative capability of the variable. The next part that we talk about over here is that of the informative capability of variable. The informative capability of the variable. So how do you assess the informative capability of a variable, guys? How do we do that? How do we assess the informative capability? Okay. So the informative capability of a variable is identified using the information values. The information value. The information value criteria. So basically, account variables which have an information value IV of more than 0.03. Right. So which have an information value of greater than 0.03 is used. I mean, are used further, right? So the second, so at this stage, variables which do not have sufficient informative capabilities are removed from the analysis. After that, the second set of variables, now the variables pass through the remaining set of variables now are those variables we being judged on the basis of the you know the basis of categorical and statistical significance. On the basis of statistical significance. Whether the variable is statistically significant or not. Now, when I talk about statistical significance, right, I would also be including all the sign ambiguity and the variable contribution. And so so this is the statistic significance. So whether the variable is statistically significant or not. So there are over here, there are three things. One is the fact that whether the p-value is less than 0.05 or not for the logistic regression model, and whether the sign of the variable is appropriate or not. The sign ambiguity reason holds on. the sign ambiguity or not, right? So if there is the informative capability, there is statistical significance. The next set that I have over here is on the basis of the multicollinearity. The multicollinearity. So that is if the VIF is greater than 2. So these are all the checks that we generally do. Now, apart from these checks, there is always a out of sample check. Now there can be some variables which go redundant in the out of sample exercise. So in such a case, those are the variables which should be removed. So the entire variable waterfall from the start to the end would be looking something like this. Right? So your entire data quality check would kind of look like, and at each stage you will be removing some of the variables, right? And then finally what would happen is, what would happen is we would end up with those variables which are the best possible variables. However however this approach is strongly recommended, this part of the variable selection is recommended if it's a logistic regression based model. So if your model is a logistic regression based model, then you need to use these methods, right? However, if it's basically a tree based model, then this part is not generally required. So if it is only a logistic regression model, then information value or etc. is required. But if it is not, then all you need to do is you need to complete the data quality till the frequency distribution, and then that final set of variables that you are left with. Then from there directly move to model design. You will create all your respective covariates, and then you use the final set of models to develop your final set of variables, right? So so that is where you kind of get to see how this thing has been done, right? So if it is a segmentation based approach like the one we are talking about over here, then your data quality check would kind of go on till looking into the categorical variables, continuous variables, doing the data quality, and from there you move on to the next one. So from there you move directly to the model design. So these steps are required, however, if your models are statistical. So if the models that you are preparing or the models that you are working on are so the models that you're trying to work on are is a logistic regression based. All right. There any questions up to this point? Okay. Great. So after we have It is model design. Model design. Model design. A model design will typically have three important components to it, right? So what is the first question that we talk about is chosen. So how is it create. Choose one. Talk about over here is that the model is created. That come out for modeling snapshot, one of the most important considerations that need to be taken for retail portfolios. So one of the most important, decisions that we can really take for these portfolios is of seasonality. Is seasonality. So when I talk about seasonality, so what is seasonal? Seasonality is the fact that that because it's a retail product. Yeah. So retail product, right? So there are seasonal patterns in the payment. Say for example, during the holiday seasons, you tend to spend more, pay less. So that so delinquency patterns exhibit seasonality for these retail products, right? So seasonality in terms of which variable? Seasonality in terms of delinquency is observed for most of the variables. I mean, seasonality for in terms of delinquency is observed in these variables, right? Now, if the seasonality in delinquency is not captured, then the data that I would prepare for my development would not be a representative data. So what I need to do is I need to capture that particular seasonality. If I am in that particular seasonality, how do I capture it? So basically, before I decide whether to use data for or whether to talk about the seasonality or not, so one of the most important things that we talk about over here will be or has to be a test for the seasonality. So we need to first of all test whether the delinquency time series satisfies delinquency or not. I mean seasonality or not. So one very easy way is to use the ACF and the PACF curve. So is to use the autocorrelation functions, the ACF, ACF, and PACF curves or the PACF plots to assess the seasonality. And this ACF and the PACF plots are generated as a part of the ADF test process or the augmented deep flood test process of the ADF test under ARIMA. Under ARIMA. So is one of the most important checks that we need to do before while we are trying to choose a particular snapshot, right? So once the seasonality is tested and the snapshots are chosen. So generally in this case, the last month, the snapshot of the last month of each quarter is chosen and they are appended together to get the whole data set. Right. Now, after the snapshots are chosen, the next part is to talk about the performance merging. Now, it is from this part that the three models bifurcate. So, your PD model bifurcates, your EAD and ECD. These three models they bifurcate from each other, right? So, this is that from this step onward till now, you are treating all the variables and together. From now on, this is where from where your variables, or I mean your data sets will kind of split. And the way that you need to structure the data, your data will be structured, right? And your exclusions will differ. So everything will kind of change from this particular part because from here you will apply observation exclusions, your performance exclusions, right? So let's start with this particular part from tomorrow's discussion. Tomorrow we'll talk about the model design of the PD, LGD, and for the QRRE segment. Exactly, we will see. So now from here, we will go back to detailed data that we have prepared, like the exclusion that we had done, and we'll compare it back with this. And we'll see that both these two data sets, the model, so how similar the model design of these two data sets or these two products have been, right? And then from here now on, so then we'll also talk about how is it that we can prepare the data for the EAD data for that particular for the retail other retail products, and how is it we can do it for this as well. So now from here we split the three models and we study each of these three models in separation, right? Okay. So thank you guys. So